going to be starting complex numbers today. So from O levels, we know that square root of 25 is 5. Square root of 36 is 6. Square root of 3 is exact answer of square root of 3 is still square root of 3, or it has some decimal equivalent. But in O levels, when we used to get something like this by mistake in the calculator, like square root of minus 25, our calculator would say math error. And we would know that we've made some mistakes somewhere in the question, so we had to recheck all our working. That's not going to be the case anymore now. Square root of minus 25 would be 5 iota. Now, what's this iota? Iota is actually equals to square root of -1. So what happens is that minus 25 can be written as -1 times 25. And then we can split the third sign. So we have square root of -1 times square root of 25, which is square root of 25 is 5. And square root of -1 is iota. So square root of minus 25 is 5 iota. Similarly, square root of minus 49 would be square root of -1 times 49, which is square root of 49 times square root of -1. Square root of 49 is 7, and square root of -1 is iota. So square root of minus 49 is 7 iota. Similarly, let's say square root of -100. So this would be 10 iota. Similarly, square root of, let's say, -81 would be 9 iota. And again, what's iota? Iota is equals to square root of -1. Another important term you must know is, or a constant that you must know is iota square. What would be iota square?
-1.
Yes, -1. So you square both sides here and you get -1. So remember this, iota is square root of -1 and iota square is -1. Sorry, iota is square root of -1 and iota square is -1. All right. Okay, next is adding complex numbers. This would be called a complex numbers. 3 plus 2 iota. This 3 would be called the real part. And 2 iota is the imaginary part or the complex part. Imaginary part, or also known as complex part. I think imaginary part is more appropriate.
Complex तो पूरा ही हो जाएगा 3 plus 2 है.
Complex number बिल्कुल. Complex number is पूरे को कहते हैं. And this is called a complex number, which has a real part as well as an imaginary part. And in case you have to plot it on the number line, then you will have a real axis here and an imaginary axis here. So that would be 3, 2. So 3 here on the real axis, 2 on the imaginary axis, and this is where 3 plus 2i lies. All right, but we'll talk more about this when we discuss Argand diagrams. Anyway, right now we're discussing how to add complex numbers. So adding complex numbers is just like adding any algebraic expression. What is 3 plus 2x plus 4 minus 5x. That would be 4, 5, 6, 7 minus 3x. So similarly, 3 plus 2 iota plus 4 minus 5 iota would be 7 minus 3 iota. So addition is just like adding algebraic terms. You add the constants together and you add the complex values together. Okay. Now let's talk about subtraction. Subtraction is also exactly the same as algebraic subtraction. 3 plus 2 iota minus bracket 4 minus 5 iota. So that would be 3 minus 4, which would be minus 1, and 2 iota minus 5 iota would be 7. Okay. Next would be multiplying complex numbers. So we have a complex number 3 plus 2 iota. With this, we have to multiply 4 minus 5 iota. So this is also like algebraic multiplication. The only thing you need to be careful about is that iota square will be equals to -1. So wherever you get iota square, you replace it with -1. Rest, it's just like algebra. So 4 times 3 is 12. Then 3 times minus 5 iota would be minus 15 iota. Then 2 times 4 is 8, so 8 iota. And then minus 10 iota square. And iota square is actually -1. So we have 12 minus 7 iota. And then plus 10. So we have 22 minus 7 iota. Another one, 7 minus iota times 3 plus 2 iota. So that would be 21 plus 14 iota minus 3 iota and then minus 2 iota square. Iota square is -1. So we have 21 plus 11 iota and plus 2. So we have 23 plus 11 iota. Okay, next we talk about dividing complex numbers. Okay. Now this is slightly different. So if we have 3 plus 2 iota divided by, let's say, 1 plus iota. Now, how do you divide this? What you have to do is multiply and divide this fraction with the conjugate of the denominator. Now, what is a conjugate of denominator? Let's talk about that here. Conjugate of 1 plus iota would be 1 minus iota. All you do is flip the sign of the complex part, of the imaginary part. So plus iota was the imaginary part, so now it becomes 1 minus iota. Can you tell me the conjugate pair of -3 minus iota? What is the conjugate of this? It would be, real part stays the same, but the complex part changes sign. So it would be -3 plus iota. What's the complex conjugate of -3 plus 2 iota? That's going to be -3 minus 2 iota. So only change the sign of the complex part. So the conjugate of the denominator would be 1 minus iota. Now what you do is you multiply and divide it with the complex conjugate. What we're trying to do is get rid of the iota from the denominator. If you remember from surds, if you get an answer like this, 3 upon under root 2, this is not an acceptable answer because you can't have a surd in the denominator. So if you're solving this without a calculator, you have to multiply it with square root of 2 and divide it with square root of 2. So now what it does is square root of 2 times square root of 2 is square root of 2 square, which becomes 2. And the numerator is 3 square root of 2. So if you enter 3 upon square root of 2 in your calculator, it will change it into 3 square root of 2 upon 2. So since you're allowed your calculator, so you don't really need to worry about surds because it's not really part of your syllabus, but you must have done this while preparing for SAT. So aana chahiye ye for SAT, but this is the theory behind removing the iota from the denominator is the same as theory behind removing the surd from the denominator. So in order to remove the iota from the denominator, you must multiply and divide the fraction with the conjugate pair. Now, what happens in the denominator? Notice we have this identity, a plus b times a minus b, which is what? A square minus b square. You'll always have this identity when you multiply with the conjugate pair. Okay, so it's going to be 1 square minus iota square. And you already know what is iota square. That is -1. So the denominator becomes 2. Denominator is 2, and in the numerator, we have to multiply these. So we have 3 minus 3 minus 3 iota plus 2 iota minus 2 iota square. 3 minus 3 iota plus 2 iota minus 2 iota square, and iota square is -1. So we have 3 plus 2, which is 5, and then minus iota. Now you can't leave your answer like this because marking scheme gives answer like this. So we have to be careful and we give the answer just like this. Split the denominator in the end. The real part should be separate and the imaginary part should be separate. So this is what the examiner expects. Even writing it as -12 iota is, I think, slightly more appropriate. So clearly show a real part and clearly show an imaginary part. Do not keep the denominator like that. Split it separately underneath 5 and underneath -. All right, let's do another example. Okay, so the numerator is 1 minus 3 iota and the denominator is 2 minus 2 minus 2 iota. Okay. So we have to multiply and divide with the conjugate pair of the denominator, which is going to be -2 plus 2 iota. -2 plus 2 iota. Okay, so the denominator would be a square minus b square. So -2 square minus 2 iota whole square. A square, a is this, and b is this. So a square minus b square So, and the numerator would be minus 2 plus 2 iota plus 6 iota and then minus 6 iota square. I know iota square is -1. And even here, this would be -4 because 2 square is 4 and iota square is -1. So this would be -4. Okay. So the numerator becomes -2 plus 6, which is 8, and then plus 8 iota. And the denominator is 4, minus minus is plus 4. So I'm getting 8 plus 8 iota divided by 8, and you can take 8 common from the numerator. Oops. Take 8 common from the numerator and we get 1 plus iota. So the answer is 1 plus iota. That's all about dividing complex numbers. Okay. Now we're solving quadratic equations. Solve the following equations. First one is z square plus 4z plus 5 is equals to 0. You can check, but factorization will not work in this question and you will have to resort to using the quadratic formula, which we will z equals to minus b plus minus b square minus 4ac divided by 2a. So we get z equals -4 plus minus, that is 16 minus 20 upon 2. So we get z equals -4 plus minus square root -4 upon 2. Now, if this were O levels, your calculator would have said math error had you attempted to solve this. But now you know what to do. -4 square root is 2 iota. So we have z equals -4 plus minus 2 iota upon 2. So z equals -2 plus minus iota are the complex roots of this quadratic equation. So you got two roots, right? One of them is -2 plus iota, and the other one is -2 minus iota. Notice that the roots are conjugate pairs. The roots are always conjugate pairs. So if you get a question like that, a quadratic equation has a root -2 plus iota, state the other root. Then that would be -2 minus iota. And there are 1-mark questions like this in the past papers. So if you're given one root, you just have to flip the sign of the complex part and you'll have the other. Okay. Now this is only true when A, B, C are real numbers. Like A here is 1, B here is 2, and C here is 5. Let me just write that down. Only true when A, B, C are real. Very soon we'll see complex equations like this. Z square let's say plus 4 iota z minus 2. So now b is not a real value. So now if the roots will not be complex conjugate pairs. So if quadratic equation has real a, b, and c, like in this case, a was 1, b was 4, c was 5, then if you get complex answers, your answer will be conjugate pairs. But not if a or b or c is not a real value and it's a complex value instead. फिर ये नहीं होता. Okay, let's see another example. Part B, which is c square minus 6c plus 25 equals to 0. So again, you might try to factorize this. You won't be able to do that. So you move on to using quadratic formula, which would be minus b plus minus square root b whole square minus 4ac upon 2a. Six plus minus square root 36 minus 100 हो गया, which is 64 minus 64 upon 2. Now minus 64 square root would be 8 iota. So 6 plus minus 8 iota upon 2, which is 3 plus minus 4 iota. And we can see that we got conjugate pairs. One is plus 3 plus 4 iota and the other one is plus 3 minus 4 iota. Okay. Now we will be talking about quadratic equations where a, b, and c are not real. For example, here's a quadratic equation. Z squared plus 4z plus 4 plus 2 iota equals to 0. So A is 1 real, B is 4 real, but C is 4 plus 2 iota not real. So it is still a quadratic equation, but the roots will not be complex conjugate pairs. Because for that, A, B, C need to be real. Acha, ab ho gaya kya? That when you apply quadratic formula, you will get a complex value inside the square root. Let me see if I have that. Somewhere. Yeah. So when you apply the quadratic formula, you'll get something like this: minus 4 plus minus square root minus 8 iota upon 2. And in some cases, you'll also have a real value here, like 3 minus 8 iota. Now, we have to discuss how to find square root of a complex number before we can move on to this topic. So we'll put this topic on hold. And for now, we're going to discuss, okay, how do we find square root of a complex number? जब हमें वो करना आ जाएगा, then we'll come back to this topic. So right now, we can't handle it. Okay. So now we're learning how to find square root of a complex. The complex number is, just give me a second, let the board fix itself. So we have to find square root of -3 plus 4 iota. Now there are many ways of solving this. If formula bhi hota hai, then there's algebra involved, which I'll use here, and I think there's one more method in the book. I will stick to the algebra method. Firstly, I used to teach the formula as well while doing this, but then I noticed that when the marking scheme break down the marks for these kind of questions, it only discusses the algebra method. It does not discuss the formula. So just to be safe, let's just do that method only. Although I'm pretty sure in special cases they do take into account any method that you've used correctly, but उस पे proper पहले discussion होती है before they allot you marks. So you may use a different method, and as long as it's correct and as long as it gets you the correct answer, they do accept it. But like I said, the marking scheme breaks down the marks according to the algebra method. कि ये step है to give 1 mark, ये step है to give 1 mark. So I will just stick to that. All right. So that is that square root of -3 plus 4 iota will also be some complex value. So I'm going to write will be equals to a plus b iota. Right? Square root of -3 plus 4 iota is some complex value. Now I will square both the sides. So -3 plus 4 iota will be equals to a plus b iota whole square. So -3 plus 4 iota would be a square plus 2ab plus b square. And b square would be b iota whole square would be -1 b square. So this would be minus b square. So -3 plus 4 iota equals to, I'm going to write the real parts together, which is a square minus b square, and the complex part separately, which is 2ab iota. Now, if you compare both the sides, -3 is the real part here, and a square minus b is the real part here, a square minus b square. So these two must be equal. -3 is equals to a square minus b square. And complex part here is +4, and complex part here is 4 2ab, sorry. So 4 equals to 2ab, which means that a equals 2 upon b, which I'm going to substitute there. So -3 equals a square, a is actually 2 by b. 2 upon b whole square minus b square, which is giving me -3 equals 4 by b square minus b square, which is -3b square equals 4 minus b power 4. So that is b power 4 minus 3b square minus 4 equals to 0. This is a hidden quadratic equation. Let b square equals u. So u square minus 3u minus 4 is equals to 0. This you should be able to solve using factorization. I'm directly using the calculator here. So I'm getting u equals 4 and u equals -1. Taking it a step back, u minus 4, u plus 1 equals 0. So now replace u with b square equals u, and b square equals 4, and b square equals minus. Now remember that this b is actually these a and b, these are both real values. Yes, I should have mentioned that here. This a and b, these are real values. These are not complex. So a is some real constant and b is some real constant. Keep that in mind. A and B are real, not complex. They are real constants. So when you square root both the sides, you're getting B equals plus minus 2. And here this is not possible. You can't square a real number and get minus 1. So here you get math error, so you write no solution. Because B itself is not complex, B is real. So the only value of B that you'll accept here is plus 2 and minus 2. Now we can find A from here. A was 2 by B. So when B is 2, when B is 2, we get A equals 1. And when B is minus 2, A is minus 1. Just give me a second. So we have two solutions. I mean, we have two answers for the square root. One is 1 plus 2 iota, and the other one is minus 1 minus 2 iota. What you need to notice here is that the answers are not conjugate here. What's the relationship between the answers? That you multiply one of the answers with negative 1 and you get the other answer of the square. Remember when we would solve this kind of equation, x square equals 25. What would be our answer? X equals plus 5 and x equals minus 5. So if you have one of the answers, you multiply it with minus 1, you get the other answer. So that's the same logic. If you find a square root of something, let's say you found square root of a complex number a plus bi, and one of your answer is minus 3 plus 2 iota, then you must know that the other answer would be times this with minus 1, and that would be 3 minus 2 iota. Okay, that's all for today. I'm going to leave you guys with a few homework questions from this topic, square rooting a complex value. And there will be, I think, 2 or 3 questions. Let's stick to 2. And once you're able to do that, tomorrow we'll solve quadratic equation that has complex A, B, or C. Take care. See you guys tomorrow. Allah Hafiz.